started this group, I've been asked, okay, what are you working on? So I'm not working on this one. I created this application just for demonstration here to talk about swarm technology. Sometimes when we talk about swarms, we talk about Reynolds algorithms. Do you know Reynolds algorithm? You have some creatures, he calls them voids. They have steering options in some kind of probability. Each void gets a steering option like adhesion or separation or following the average direction for a period of time, and then it chooses another steering method. So I took it and changed it a little bit, and in the following this Sputnik and virus, I created a system with the parasites. So we have this creature that has some joints, moves like a snake or some long creature that you can add some joints to it and or reduce it, and we can have a look at it. So this is the creature. He picks some points randomly and gets there, and then picks another point, and so on.
Did two creatures just become one?
Yeah, it's one creature.
It's one creature.
Just the joints come together and.
Okay.
It's leaving.
Okay. So we have this creature, and I was thinking what will happen if I put some parasites on it, and let's say 100 creatures that follow him. Okay, so how do I make this creature follow this one? I use Reynolds algorithms for picking some behavior in certain probability and for a certain period of time. I can show it to you here.
But before you go on, is the head different than the other pieces?
Each one follows the one that before it. So you have the head controls the creature.
So the head has a different algorithm,
yes.
basically. Yeah.
So
and everyone follows the
entire creature is effectively a swarm then?
No.
So the head is the only one that doesn't need to follow
I
something.
don't understand why the answer is no to that question. I thought
because it doesn't follow any non-deterministic behavior. It's very deterministic. It picks up a random point, moves to this point. The next joint just follow it, keeps a distance from it.
And each joint only interacts with the joint ahead of it or behind it?
So if you were to scatter them, they would all come back together in the same order once again?
Yeah.
Okay.
Oh, so they know who's ahead of them.
Yeah.
It's like
They've all got numbers.
Yeah, this is not the
Wait a minute, they've all got numbers then.
number. Just they know exactly who's before them.
5 has got to follow 4.
Yeah.
Oh.
Oh, that's
They
nothing
don't just
special.
link together like magnets.
That's something
in
special.
order.
Hello. Okay, that's because of the projector, the size of the screen. Okay. Come on. Okay. So we
Come back.
so that's the next improvement. I'll put some instead of random.
You have small typo preferences.
Yeah. Come on, give me a slap. I was in a hurry.
Oh, sure. Would it help to move that slider?
Yeah. But I want to add these parasites here. Okay. So when we see this creature, it will follow by a bunch of parasites that. Here they come.
Okay.
All the parasites.
So you have 3 different steering modes. The blue one means the cohesion, green follow the average direction, and red is separation. And we can play with it. Each one of them, they all have the same speed. They all have the same speed. They have maximum radial velocity. So if they are very fast and they can have a very slight radial velocity, they can separate. So they cannot turn very fast.
What are you talking
They
about?
cannot. Each one of them.
The viruses?
Yeah.
Because they seem to be.
They cannot they cannot turn very fast. Or I can change the maximum turning angle. So
Why are
let me
they
show
all
this.
sticking together too?
Blue one means that they want to get into the how do you call it? The weighted the main weighted point. How do you call it?
Aggregate?
Center of mass.
The center of mass.
Of the blue
center of
ones?
mass. Of
Or of all of
the parasite that it can see in a certain range.
Ah.
So they have, each one of them has a partial information. So I can play with it.
So they aren't actually attracted to the creature. They're attracted to each other.
Just a second. Okay. That's a good point. That's a good point. What are they attracted to? We'll follow it in a second. So I can play with the number of parasites here, and more, remove, or and get them more speed, add some radial velocity. So if I increase the radial velocity, it means that they can turn very fast. So you can see that they are concentrated here. But if I'll decrease it, it means that they cannot turn very fast. So be more spread around. I can play with the weight, the weight of each option of, let's say here, separation, cohesion, and alignment, and so for the time that I pick up for each mode. Range of interaction, that's a huge one. Each creature can interact with its own kind. So these parasites can interact with other parasites, but they can also interact with something that I call phantomoids. So it's like voids, but phantom voids, which each creature, which the host creature can have. So if I have this creature, I have also these guys, phantomoids, that are phantom points on the back of this creature that the parasites follow. So we have this host, and if I have used the host as an attraction creature, it will be more deterministic. It will follow, the parasite will follow the same location all the time. Okay, nothing will change. So I added these phantom objects that goes around the creature, and the parasite follow these phantom dots, phantom objects. So right now I have these 2 phantom objects, and they follow both them.
So why?
The red
I
dot?
don't understand the principles that you're making, the choices. So why did you choose to add the phantom?
Okay, so if I have this creature, And I have these voids, okay? And originally the voids are following each other, okay? So each one looks around and see the other behavior and do cohesion or separation or alignment according to its neighbors. Since I wanted them to follow this main creature, I had the option of taking the central mass of it, or the head of it, or the tail, or some random point, and follow this point, or refer to this point. But I didn't want it to be constant point. I wanted it to be somewhere here, along this line.
Couldn't you have used whatever, like the nearest ball that makes up
Yeah.
the...
I could have done that.
Okay.
I could have done that.
Why did you choose the family?
I wanted it to be more dynamic. I wanted it to be that everyone follows the same object and not referring to. If I had this one referring to this joint, this one referring to this joint. For me, it will be less interesting than having this one following an object here that moves around and they follow it on top of this creature.
Okay, which, I mean,
It's nothing in nature.
There are really possibilities. I mean, you could have
Yeah.
an environment, you could
Exactly.
model, some kind of nutrient that's in the environment, and,
Yeah.
and whichever one of these balls
I didn't do it
happens to have
because
got
I
the most
read
nutrient on it, they
that's
go
the
after
way a creature behaves.
that. Okay.
No,
Well,
because it was fun.
Okay.
So
Maybe it's
if you...
this is,
go ahead.
this is just a way to have a separate center of control, and now you can have another center of control, and say they will follow, say, some point in between them, etc. So you can add complexity to it.
Yeah,
It
exactly.
kind of breaks out.
I add more phantom objects like that. But the fun things that I found here is that when I play with the options, like when I play with the weight, I can play with the weight of the relation to this phantom object in opposed to the relation to your kind of creature, and I can create several groups. I can create a group that follow this one, and I create a group follow the other one, and so on. So more condensed groups separated, and then they collide and create new group. So it's very nice to see that you can control the parameters and make the group separate, for instance, according to when they cross or.
So what do you think you might hypothesize here, and what might you discover playing with this?
First of all, the goal was to play with it. It was fun. And the other thing was to. I wanted to see how such a group that behave according to or take out some of the parasites that are not so close to this main creature. So they will have incentive to be as close as they can to the main creature. Okay, so they will have incentive to be as close as they can to the main creature, and that will dictate the percentage of their steering modes. Because right now it's something that I control it. I control the percentage of creatures that do adhesion or alignment and so on. And I want it to be something that can be learned according to the environment.
Would you give each parasite like a random
Random rules?
I will give it. I will give him a choice.
Mm.
So you can be whatever you want each time and pick it up and have some strategy, and I will make the whichever taken out, and they will multiply, and
So some kind of genetic algorithm.
it will be some kind of evolution.
Okay.
I don't know if genetic algorithm, but yeah, they will have strategy, and the dominant strategy will have more chances to survive.
It doesn't have to be purely physiological. It
Yeah.
could be behavioral, it could be intellectual, right?
Yeah, yeah.
So
That's the main issue. It's not biological. It's more behavior and social interaction.
What have you noticed that's caught your attention with their behavior? What,
Yeah. Or
well, the way they behave.
Yeah.
Any interesting behaviors?
yeah, interesting behaviors. Yeah. The main thing was the importance of the speed. The speed. So if they speed up too much and cannot turn around fast enough, it goes out of control. So you need to stay inside some kind of envelope to have the creatures behave like you want.
What do you mean by out of control?
They go. It's not out of control. They don't keep
They
each
occupy
other
a larger
together.
area, but
Hmm?
they occupy a larger area. But
They occupy a larger area, but they get out of the interaction range.
Can you just
So
illustrate?
each one of them,
Okay.
each one of them has an interaction range. I can
Okay.
show you.
So they spin off and they're no longer related to the others at all.
So it's all that she can do whatever she wants. I'm the one that asked
It's going to be
for.
on the web.
Yeah.
Yeah.
Okay, you can see that they will do what. Yeah.
They do what they want.
They do what they want. Okay. So let's correction. And okay, another thing is the collision range. So you can see here that they all can get together outside of the screen. But
Get to see the stragglers.
Can you see it on your laptop? Can you
yeah,
see
you can see it.
Can you just turn on the laptop?
Yeah, it would be easier.
Do they behave differently when they're not being observed?
We're doing amazing things right now.
They want privacy.
No signal, they got it.
This is better. Oh, this is my email.
They're reading your email now?
Yes.
It's not
Email
Google.
virus.
It's from his wife.
Now you mentioned, you called these parasites.
Yeah,
Do they actually affect the host?
not yet.
Well, I was thinking, if you do have a thing where they affect the host, maybe
Yeah.
causing a problem with its metabolism, something like that, perhaps you could have more than one host on there with different inheritable behaviors and have them, their fitness algorithm being avoiding having parasites, you know, having the
I
parasites
was-
swarm to other ones.
I was thinking about more on collaborative stuff, about more, okay, I'm affecting this creature, but I want to keep him alive.
Sure,
So, coexistence.
sure. Or perhaps even, you know, some sort of synergistic thing
Yeah.
where they actually benefit the host.
Yeah, yeah. So, finding the way to make him bigger,
There's,
more productive, or, yeah,
there's a very large body of theory about parasites and how they deal with those trade-offs.
yeah, yeah. So, we have here, I can make it. I can play a little bit with the gap. the creatures, so you can see it more clearly.
I wonder if you could have like the equivalent of those cleaner birds or the cleaner fish.
Yeah, that was in my mind when I was playing with that. So some kind of coexistence. And what else? Okay, so we have this collision range, which means that they cannot be, each parasite cannot be in a certain distance from other one. So it has some space that it requires. So it also affects the dynamics of these creatures.
But
So
they do collide, right?
They don't get into a smaller distance than.
So they don't collide. I see.
So it's like birds. They see each
Okay.
other and move a little bit.
But they do collide with the kind of main body that they follow, right?
Yeah.
So initially, I thought it was gonna be like birds, like that all these
Yeah.
little units would
Yeah.
all have the capacity to be the leader.
Yeah.
Right?
No. These creatures have no leader.
No, but I meant
The big one.
the big one.
The big one is
Elements of
just
the big one.
dummy stuff that they need to follow. It doesn't have any special thing. It's just a creature that these.
Yeah, but I mean,
Parasites
if it were like birds, then any one of those units would have the capacity to be
Yeah.
the leader,
Yeah.
and they could
Yeah.
be in any order,
Yeah.
and they would know
Yeah.
what to do.
Yeah. So this is not a flock of birds. It's just one creature with many joints. But I can separate it to different groups.
How does the leader decide where he goes next?
Just pick random point and.
Random points?
Yeah.
You might want to consider adding a concept of food for the host.
Yeah.
So-
Yeah. That was. I wanted to use the carousel with some food instead of making going out of the screen. So
Hmm.
and
You can make them flesh-eating bacteria that eventually eat the host.
yeah, they don't.
Under
want to
certain
do that.
conditions.
For
Yeah.
next month's Halloween meeting.
Okay.
Time of year. The moon is full.
Okay. This is it.
Thank you. So,
Well,
let me brave the projector.
one quick question. So how does this relate to your main
Doesn't
research?
No, no. The main goal was just to play with here. I heard about other people work here, and my direction is different. So I didn't do any genetic algorithms here. I play with it, but nothing special. I'm more interested in a collaborative behavior of many autonomous entities with partial information. I'm interested in emergent behavior. So you have creatures or objects or autonomous behavior or autonomous entities that can look, can sense part of the entire society, and they decide what to do, and from that something bigger happens. That's the things that I'm doing.
What did you learn from the project you did there?
What did I learn?
Yeah, that you weren't aware of before you started.
So, first of all, it wasn't so hard to make it stable as I thought.
Okay.
I thought it would be more hard. It would be harder to make it stable.
Was there a point where the boys, movements just kind of came to life to you? That, previous to that, they were just kind of going all over the place, and all of a sudden they
No, it started as
coalescing.
something that came alive. So it was meant to be. So that's they started as going in some kind of circles and yeah.
Okay.
And that's the start. So it makes sense. But yeah, but there are so many variables, that I can play with, and
Where would you like to take it?
to the more the coexistence stuff. So to find the balance. That's the thing that interests me. So how do you have this ecology that one doesn't overpopulate or over exploit resources?
Got a balanced ecosystem.
Yeah.
Thank you. Cool.
Cool.